Okay, Assalamualaikum and hi everyone. So we see again. So today I will discuss about the relationship between pressure and concentration. Right, so we use the formula of ideal gas equation PV equals to nRT, and then we rearrange P equals to N over VRT. So where N is referred to mole over volume is referred to the molarity. So this is equal to the molarity. Okay, so from here at constant temperature, so which means temperature is constant. So we can see that the pressure is directly proportional to the molarity or molar concentration. Okay. Alright, next, so these are the unit for each of the variable in the PV equals to nRT. Okay, so pressure is atm, volume should be liter, mole, N is equal to mole, should be in mole. Kr, the unit should be atm, liter per mole per Kelvin, that is 0.08206, and temperature should be in Kelvin. Okay, so we want to derive Kp equals to Kc. Okay, how to derive Kp equals to Kc RT delta N. So start with this general equation, right? So first we have to write the Kc expression like this. So and then label, this is equation 1. Okay, next write the Kp expression. Okay, so next, this is equation 1, equation 2. Alright, so by using ideal gas equation, alright, so rearrange PV equals to nRT to become P equals to N over VRT, where N over V is referred to the molarity. Okay, so for example like this, in Kp expression there are 4 partial pressure, and all these 4 partial pressure you have to relate it with the ideal gas equation. So which means Pa equals to concentration of A RT, and then label this equation number 3. Okay, for partial pressure B is equal to concentration B RT is equation 4. Okay, for partial pressure C, concentration C RT. Okay, this is equation number 5. Okay, and then for partial pressure D, concentration D RT, and then label this is equation 6. Alright, so next what we do, since we want to write Kp as the title, so you have to substitute 3, 4, 5, and 6 into equation 2. Then you substitute into this, each of the partial pressure here. Okay, next, because this is power of, okay, so we can, okay, this one times with concentration power of C, now become concentration C power of C. Alright, so okay, concentration D here, also power of D, concentration A, power of A, concentration B, power of B, and then RT here. Okay, RT we can factorize since it's just the same. Sama kan? Same. Alright, so power of, okay, this one we can add. So C plus D. Right, since this is divide, so minus, okay, A plus B. Okay, and then this is equation number 7. Alright, substitute 1 into 7. So 1 here, this is referred to Kc. This is Kc. This is Kc. Alright, so RT. Okay, this one this is referred to the sum of mole of product. Okay, minus sum of mole of reactant. So that's why we can write delta N. Delta N means changes in mole. So where moles of gases product minus moles of gases reactant. Okay, right. Okay, so for example like this one, we want to derive for this equation. So first of all, we have to write the Kc expression. So concentration Hi squared over concentration H2 times concentration I2. So this is equation 1. Then you have to write the Kp expression. So partial pressure Hi squared over partial pressure H2 times partial pressure of I2. And then you have to label this is equation number 2. Okay, and then by using ideal gas equation, PV equals to nRT. Okay, so rearrange P equals to mole over volume RT. Okay, alright. So where mole over volume here is referred to the concentration RT. Right, so refer back to the Kp expression, equation number 2. There are three partial pressure, and then all these three partial pressure you have to relate it with the ideal gas equation. So therefore P partial pressure Hi is referring to the molarity of Hi RT. Label this is number 3. Okay, partial pressure of H2 equals to the concentration of H2 RT. Okay, question 4. Partial pressure I2 equals to the concentration I2 RT. This is number 5. Okay, next you have to substitute 3, 4, 5 into 2. Okay, so Kp is equals to, right, so bracket concentration Hi RT power of 2 over, okay, next concentration H2 RT times concentration I2 RT. Okay, so now, so we have to split the concentration with the RT. So it will become like this, squared. Okay, so now factorize RT. Okay, so we have 2 minus, this is power of 1, power of 1. 2 minus 1 plus 1. Okay, and then, so this is referred to Kc. Kc RT. Okay, 2 minus 2 equal to 0. Okay, we know that any numbers that is power of 0, it will become 1. Okay, so therefore, Kp is equals to Kc. Alright, so these are the example of calculation. Right, so you take a look. Right, so given to you the Kp and we want to find out the Kc. Calculate. So meaning that no need to derive. So just use the formula of Kp equals to Kc RT delta N. So Kp is already given. Okay, Kc we want to find out. So R is equal to 0.08206 times temperature is already in Kelvin. So delta N. So delta N here is referred to the sum of mole of product minus sum of mole of reactant. So this is 1. Okay, so which means 1 minus 1 plus 1. Okay, which means suppose you get here negative 1. Power of negative 1. So therefore we want to find out Kc. So the value here is 3.2. Okay, for B, so we can use Kp equals to Kc RT delta N. So since this is in solid, we not consider. Okay, so Kp here is 28.5. Kc we want to find out. So let's say we want to calculate the delta N. So here is 1. So 1 minus 1. 1 minus 1 is equal to 0. So RT 1 minus 1. So therefore we get here Kc equals to 28.5. Okay, so 1 minus 1 equals 0. So therefore Kc equals to 28.5. Okay, next C, Kp equals to Kc RT delta N. Kp is already given 49. Kc we want to find out. RT, okay, delta N. So delta N here we have delta N, we have 2 minus 1 plus 1. So 2 minus 2, 2 minus 2 equal to 0. So therefore Kc is equals to 49. Okay, that's all for today. Thank you and Assalamualaikum.